Hi class. We were talking about using NetBeans and the online debugger to step through our code so that we can see what's happening line by line. We start by setting a breakpoint. This screenshot is showing a breakpoint set on this line of code in NetBeans. And then we run our application using the debugger, and when the execution gets to the line where we set our breakpoint, execution stops or halts or pauses, whatever, to let us take over control. We can see what the value of our different variables are, and then we can step through our code from that point forward line by line. We have some different options. If we would like to step over a method and just run it to completion without seeing each line of code, we can press F8 or choose step over. If we want to step into each line of code and step into the code that's in methods, we'll press F7 or step into. If we want to step out of a method and continue till the end, we'll press Control F7. If we want to continue to the end of the execution of the program, we'll press F5. So let's try it. In NetBeans here, I have our application open that we were working on in the previous video, where we are creating an instance or multiple instances of a circle object. And a circle is extends the geometric object superclass. So we have some concepts going on here. So in my main method, I've set a breakpoint here on line 9. Lots of ways I can do that. I can just click over here on the line number and that'll set a breakpoint. I can right click and set a breakpoint. Turn it back off the same way. And many other ways that I can do things using my debug menu. Set a new breakpoint or toggle the breakpoint. So whatever we want to do there, we'll set our breakpoint here. Now this line of code is within the for loop, and in my for loop we're creating an instance of a circle to put in our MyCircles array. Our MyCircles array has 10 entries. That's quite a bit of steps to step through in our debugging session. So I'm going to change that to 3 just for us while we're debugging. Okay, so I have our breakpoint set. In the toolbar, instead of choosing the run, I'm going to choose the debug option. My program begins, and now it's waiting here at line 9 where I set a breakpoint for me, so it's going to just hang here for a while. Down at the bottom, in at least the way my windows are set up, I see my variables window showing me all the different variables in my program and their current values. I can see my IX variable, my counter that's set at 0, my MyCircles array. My MyCircles array is an array full of circles. My circle 0 object, my very first one, already has an instance here. I'm sitting here ready to execute that line of code. So let's do that. Here's my step into. I'll click it, and let's see what happens when we go to actually instantiate the instance of this circle. First of all, we jump into our circle class and begin executing code at our circle constructor. Because we passed one double variable to our circle constructor, we're running the constructor method that expects a double variable. This constructor calls this or another instance of a circle constructor. The instance that it calls expects a double, a string, and a Boolean. So let's click step into and see what happens. We run the method that has those expected parameters or arguments, a double, a string, and a boolean. So it's another instance of our circle constructor. In this instance, we call our superclass constructor and pass it our color and filled variables. So if we step into, we'll see that we move to our geometric object class, which is of course our superclass, and we're running a constructor in our superclass that expects a parameter of a string and a boolean. If I keep stepping into, we'll see that we're going to use our object class, the system object class, and we don't have source available for that, so whatever happened there will not be aware of each line of code. But that brings us back to our instance of our geometric object. So we'll continue on with that constructor. First, we'll set our color variable to white. So we see that variable down here, color is white. And if we continue stepping into, we'll see that we're going to set our filled property to whatever was passed to us, and we had a false value passed to us. Okay, so that finishes up our geometric object constructor. So if we continue stepping through our code, we'll return to our circle constructor, where we'll set our radius, which is the only instance variable that we have for our circle class. We'll set its value to the radius that was passed to us when the constructor was called, which is 5, and we'll continue executing. Now we return to our original constructor to end it, and then we return to our main class with that instance of our circle object now complete. So if we look in our MyCircles array, we'll see that that circle object 0 has a radius and it has some inherited properties, its color and its filled property. So I can go ahead and just step into that repeatedly and run it again. Check my for loop, create a new circle, set up my geometric object base class, then extend it with my circle properties, and then create another circle because my for loop executes again. And now I should be ready to finish up my for loop here. Let's check what's the value of our ix variable. It is 2, so when I check it again, let's see, it will not be less than 3 anymore. Let's check. It increments it. It's 3 now. We're creating another one. Should be our last one. And now we'll exit out of our for loop. Why are we not exiting our for loop? Finally. Okay, now we're going to use the for each loop to print out the items in our circle array. So we'll do our print. Now again, we're using a system class. We'll see some of that code. This is where we want to step out. We'll see what it's like if we step over. Can I Step over. Come on, you silly. I don't want to run all the way to cursor. Step out. There we go. And step out. Finally back to our code. Now each time we have an instance of our array, we're going to be running that print. So let's see what we're getting on our output line here. Our first one has printed out. I'll keep stepping into here. And we're going to do our get area because that's what we're printing out. And then we come back and we're ready to do our print line. So I'm going to step over. That got us back pretty quick. That printed out our second item. Step into, we'll see that we do our get area method and return to run our print line statement to print that out. We'll step over a few of these methods and we're done there. So we can see what's happening with each entry as we print it out. Now, we'll step over all of that, and we've got all of those printed out, and we're to our sort method. So in our array.sort, we're going to be sorting our MyCircles array. Let's see what we can see with our debugger. Some system stuff. Oh, and then look, it's running our compare to method. So sure enough, in our compare to method, let's see what our variables are. We have O, the object that was passed into our method, which has a radius of 5, and then we have this, the object that is the instance of our circle, our current circle, and it's 4. So we should see that our this is going to be less than. Let's step through it. And we got to get our area of our first one and run the get area of our second one. And then, sure enough, we say, no, this one is lower. So again, we'll keep checking. Now we're looking at 4 and 3 again. O now is a radius of 2, and our this item is a radius of 1. So we're getting through all of the different instances of our circles to decide which is larger than which other. And we're done sorting. So now if we print out, again, we'll see all of this happening. I'm going to step over and step over. And now we should see all of our output. So here's our newly sorted output because of our compare to method. So we're able to use the debugger to step through our code line by line. This is really helpful if we're getting unexpected results, because by using the debugger, we can see what's happening, where things are running a little bit differently than what we were expecting. So use the debugger and breakpoints for all of your debugging needs. I'm going to click stop to stop running this program. and minimize it to return back to our presentation. So the online debugger is a very, very helpful tool. I can't encourage you enough to use it often, use it to step through any code that you don't understand line by line. The call stack on the system is a history of modules and which module has called which other module. It's called a stack because the first module will stay at the bottom of the stack and newly called modules will be at the top. So if we look at this call stack window right here in this debugging session, we can see that the main method called a method getInt within range, which called the method getInt, which called getDouble within range, which called getDouble, and finally calculate future value. So we have a huge stack here, and again we can see what call sequence has occurred by looking at that window while we're using the debugger. When we have our application all debugged and tested, we're ready to distribute it and give it to others. One option that we have for distributing our application is creating an executable jar file or Java archive. This Java archive file stores all of the classes and resources that our application needs, and we could manually distribute this file to our users and show them how to run it. So this is a one way that we can do things. It doesn't cause any sort of security problems, but we do have to make sure that the Java runtime environment is installed, so that could be a manual install. And the code is not automatically updated. We don't have any sort of update capability. So if the application changes, you would have to redistribute the code. We'll look at our jar file or create a jar file here in just a second. Now another option for distribution is by running your application as a Java Web Start app. It would be placed on a website and users would be able to download the application from the web, cache it locally on their machine, and run it. So this is really nice because we can always make sure that the correct version of Java is installed. It happens automatically when they download. The code is automatically updated if we make a change because everybody's always running the latest version. Cons are there's a lot of security restrictions and it makes it really difficult to use, almost impossible. We also could use a third-party installer program. An installer program would let us create a customized install script for every operating system that we wanted our application to run on. So this would be great. The application installs and it would look like a professional desktop installation. The correct version of Java could be installed as part of the installation process, and there really are no security restrictions. This is a standard way of installing software. The cons, though, the code is not automatically updated after the install. Most of these installer programs are pretty expensive, and this approach requires more work to set up and configure. So all of these options are available to us when we want to release a version of our software package. Now, we're looking here at the properties for a project in NetBeans. And on this build option under packaging, we see the options that are standard for creating a jar file. Once we've got the jar file created, how we run it is going to depend on the operating system. If we're on an OS X type operating system, we can open a terminal window and run the jar file. If we're running on Windows machine, we need a command prompt window if we're running a console-based application. Now, if we're running a graphical application, we can just double-click on the jar file to execute it. But a console application like ours, we're going to need to go to a command prompt and enter a command like this to run our jar file. Let's see if we can do that. Here's my program. And this application is to the geometric object application that's building a circle. I'm going to eliminate my breakpoint here, and I want to generate a jar file. So I could look at my project properties. I right-click on my project and choose properties to find those build settings that they were talking about in the presentation. I could go ahead and compress my jar file if I want. All of the rest of these options look good. I'm going to check my run option and make sure that my main class is set to my main class. And I have other options that I could set, but that's all I really need. So I'll click OK. Now to generate my application's jar file, I'm going to use the Run menu and choose Clean and Build Main Project. I should see a message, Finished Building Comparable Objects. That looks good. Now I can go to File Manager, but I could also look at the Files tab here in NetBeans. And on the Files tab, if we open our folder for our project, let me close it all. Here's my project folder. If I open that, I'm looking for the distribution folder, or dist. When I open the dist folder, sure enough, I see my jar file that I'm looking for. So I did get a jar file created. So what I'd like to do is see this dist file in File Manager. So I'm going to open, or File Explorer, sorry. I'm going to open File Explorer. I have my NetBeans project saved on my D drive. So I will go into the Documents folder where I have those. Here's my NetBeans projects. And this is my Comparable Objects project. So I'm going to open that project folder, my dist folder, and there I see my jar file. Now I just need to open a command prompt from this folder. So I'll just click up here in my address bar and type CMD and press enter to open a command prompt. Now I can just simply type Java -jar and then the name of my jar file. .jar. There, that's better. And then I see the output from my program. So I can always run something, a jar file, at the command prompt, and I can always get to a command prompt just using File Explorer and typing that CMD up there in the address bar, and it'll open the command prompt for me at the current folder location. So it makes it super handy to get to a command prompt to test things. Okay, so I could distribute my application that way. That's about it for Chapter 6. That's our content. Up to you to use the debugger. Make sure you start getting familiar with it. It's an unbelievably useful tool. You don't know how much you're missing it until you try to use it. So let me know if you have any questions. Thank you.